Alright, so for this particular problem, the one thing I forgot to tell you is that it is a trapezoidal prism, which means that this is indeed a trapezoid, and it looks like a prism, and it really is supposed to be. Now, it's called a trapezoidal prism because this is the same exact thing as that. They're all connected by line segments. And so if you were to cut it like bread anywhere along here, you would end up getting a trapezoid. Whereas it's not a rectangular prism because this rectangle and this rectangle here are not congruent to each other. So we have this piece of information here. We have a 7 and we have a 5, so we know that that is not isosceles. And so we need to obviously draw in our height because we need the height in order to find the area of our trapezoid. So for this one here, I need to use a right triangle trig. So I'm going to use sine because sine is equal to the opposite over the hypotenuse. And then we go ahead and plug in 7 times the sine of 35, and we get 4.02 when I round up. And so that is that one there. Then I have two choices. I can use Pythagorean theorem, or I can use cosine. Cosine is better because cosine will give us a more accurate number here because I'm not using a rounded number in the equation. So we'll do cosine of y is over 7, so we would have 7 times the cosine of 35, which would give us 5.73. And so students were asking me today, what do I know about this? If this is parallel, then my heights are the same. So I have 4.02. I had a lot of students getting like 8 and weird numbers down here, and I knew that they were wrong because this is a 5, so I know that this number definitely needs to be smaller than a 5. So I don't know this angle here, and though I could find it, really all I need is this side here. So Pythagorean theorem is definitely my best option. So we'll do 25 minus 4.02 squared. Oh, and that is 8.83, but that is what z squared is. That must have been how students got that wrong today. And so then I would square root the answer and get 2.97. So students said, if this is a 5, can I just say this is a 3, 4, 5? Well, it's not exactly, and so your answer will definitely not be as accurate as others. We want to make sure that we're using as exact of things as we possibly can. So this here is 4, so this is also 4 because I've got a nice little rectangle going on there. So for the area of my trapezoid, we've got 1/2 of the height times the two bases added together. And the bottom base is 4 plus 5.73 plus 2.97. 12.7. So I'm going to go ahead and add the two bases together, times it by 4.02, and then divide by 2. So that is the area of one of my trapezoids. And for the volume, I simply need to multiply by the height. The height, I know it's weird because it's on the bottom, but the height is the distance in between the two bases. So I multiply by height, so my volume is 402.80. Now, for my total surface area, the nice thing is I already have two of my surfaces. I have my front and my back. And I have this face here, which is 5 times 12 is 60. I have the top, which is 4 times 12, which is 48. I have this side over here, which is 7 times 12, which is 84. And then I have the bottom, I already lost what that was, so 5.73 plus 4 plus 2.97 times 12. Not getting down yet. So my base is 12, full base is 12.7, so times that by 12, and I get 152.4. And when I add that, 4 plus 48 plus 60 plus 33.52, I get 411.44 for the TSA. Well, hopefully that helped. Let's go ahead and look at B. B, we have a cylindrical birthday cake with a diameter of 10 inches, D10, R5, good practice to take. And I'm cutting a piece, so this would be 5. The height of my cake was 4. I have 30 degrees. And let's go ahead and find volume first. Volume is the area of the base times the height, so the base area is 30 over 360 times the area of the whole circle, which is pi r squared. So reduce, 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 and you get 25 pi over 12, but the height is 4, so I get 25 pi over 3 for volume. Now, for the surface area, I'm asking for the total area that has frosting on it. So frosting is here, which we already decided was 25 pi over 12. And then the frosting is back there, which when I flatten it, the height is 4, and this length is the arc. So again, 30 over 360, but this time it's times 10 pi. Reduce, 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 reduce. 2 goes into that, and 2 goes into that, which gives you 5, 6 pi. So when we multiply them, we get 20 pi over 6, which, to get a common denominator, I'm going to go ahead and have 40 pi over 12 and add them together to get our surface area, not total, but just surface area of frosting. So that would be like the FSA for frosting surface area. All right, hopefully that helped.